right, so there are two more phase changes we have yet to discuss. The first one is melting, which I hope you would have some background knowledge in what melting is, and I would think you would if you've ever been in contact with an ice cube. It's the change from a solid to a liquid, so therefore it's the opposite of freezing. And this is one of those processes where energy is absorbed, meaning we have to gain energy. Ice has to gain energy in order to melt, right? And when something gains energy, what happens to the motion of the molecules? They begin to speed up, right? And when they begin to speed up, what happens to the attractions between molecules? They begin to become less attracted, okay? So same thing as kind of like, let's say, boiling or vaporization when you add heat to it. Heat travels from hot to cold. It gets to the molecules. It causes them to move more. By moving more, they break up. The attractions break up, and they change state. So in this case, we go from a solid to a liquid. So we have a solid, which was in fixed positions. You add heat, those molecules start moving faster. As they start moving faster, they start to break out of their fixed positions. So that is the cause of melting. And then just like freezing again, we have a melting point, which interestingly enough is the same temperature as the freezing point, just going the opposite way. It's getting warmer. Temperature at which a substance changes from a solid state to a liquid state. And just like freezing point, this is different for different liquids. And just for your FYI, melting point of water is 0 degrees Celsius. You should know that it's 32 degrees Fahrenheit, but we're in science, we don't use that F word. And the second process we have yet to talk about is sublimation. And that's what you saw the other day when we did the dry ice demo. The dry ice was solid. It was solid carbon dioxide, about negative 80 degrees Celsius. It was really cold. And what they do is they take carbon dioxide, compress it to a gas. So they use deposition to get it into a solid. And so it's in the solid state, and it's so cold, and it comes in contact with air that's so warm that the air heats those molecules up so fast, they move so fast, they break free of their attractions at such a fast rate that they completely skip the liquid phase. So they just skip it. It's so much energy at once that the molecules just can't handle it. They break up, they become single and ready to mingle again, straight into the gas state. And this here is just, this is basically just saying that when we're talking water, or during a phase change, so freezing, melting, vaporization, sublimation, etc. During a phase change, temperature does not change until the entire phase is complete. And you can see that in this graph here. We have something, an object, water, that started at negative 20 degrees Celsius, heated up to 0, which is the freezing and the melting point. And you notice that time is passing, energy is being added, because energy is down here on the bottom. Energy is being added and time is passing, yet the temperature is not changing. We are melting, but the temperature doesn't change. And once we're completely melted, you notice the temperature go up again all the way to 100, which, if you remember correctly, is the boiling point of water, and the condensation, well, we'll just say boiling point of water. So again, we're adding energy. Energy is increasing, yet our temperature of our water isn't changing. And then once we've completely vaporized and boiled out, we go back to getting hotter. A gas can get hotter. And you're probably wondering, well, why does that happen? Why does temperature not change? So here's an example when boiling a pot of water. So we're starting off with molecules that have a lot of energy and some that don't have a lot of energy because temperature is an average. So the ones that have the most energy are, just like we've talked about before, going to vaporize and escape. So as a result, the remaining liquid has less energy. It's cooler. Okay? But there's still heat being added, right? We're still in the middle of a phase change. So heat's still being added. You're adding energy to the molecules. The molecules are speeding up. They get to the surface. They escape. We are left with cooler liquid. And then we add more heat. The molecules speed up. The fastest ones escape. And then we're left with the cooler liquid. The molecules heat up. So you can see that we keep going until all the liquid is gone. So during a phase change, temperature does not change until the phase is complete.